Assalamualaikum. Welcome back to Sir K Loves Physics and Chemistry tutorial. In this episode, we analyze a stoichiometry problem involving a limiting reagent chemical reaction, molarity of a solution, and the ideal gas law. So join me till the end of this presentation. Watch and learn. The question is, letter A, calcium carbonate reacts with hydrochloric acid to produce carbon dioxide gas, calcium chloride, and water. If 35.3 grams of calcium carbonate reacts with 100 milliliters of 6.00 molar hydrochloric acid solution, how many liters of carbon dioxide gas will be produced at a pressure of 745 torr and at a temperature 23.0 degrees Celsius. And question letter B, what volume of carbon dioxide gas would be obtained at STP or standard temperature and pressure? So for our solution, we first write the balanced chemical equation as shown here. So the given reaction says that calcium carbonate reacts with hydrochloric acid to produce carbon dioxide gas, calcium chloride, and water. So when translated to an equation or chemical equation, we get this already balanced chemical equation as shown here. Calcium carbonate plus 2 moles of hydrochloric acid forming the products calcium chloride, carbon dioxide, and water. Based on this balanced equation, 1 mole of calcium carbonate reacts with 2 moles of hydrochloric acid, forming 1 mole of calcium chloride plus 1 mole of carbon dioxide gas and 1 mole of liquid water. We can now find the mole equivalent of the given 35.3 grams mass of calcium carbonate. Okay, so we simply divide this given mass, 35.3 grams, by the molar mass, all right, the predetermined molar mass of calcium carbonate, which is 100 grams per mole. And that will give us 0.353 moles of calcium carbonate. All right. Now, the given molarity concentration of the chloride or hydrochloric acid is 100 ml, all right, with a molarity of 6.00 molars. Okay, so we can determine the equivalent number of moles of hydrochloric acid, okay, by simply multiplying the molarity 6.00 moles or molars, which is in fact the same as 6.00 moles per liter. So multiplying that by the given volume of the solution expressed in liter, 0.100 liter, we will get the number of mole equivalent, which is 0.600 moles of hydrochloric acid. Okay? Now, the molar ratio of hydrochloric acid to calcium carbonate, okay, is 0.600 mole divided by 0.353 moles. All right, so the ratio, molar ratio, is equal to 1.70. All right, and based on the balance equation here, the stoichiometry ratio of hydrochloric acid to calcium carbonate is 2:1, all right, or 2.00. And since the molar ratio of hydrochloric acid is less than the stoichiometry ratio, all right, we can conclude that hydrochloric acid is in fact the limiting reactant, all right, while calcium carbonate is the reactant in excess. All right. So this means that we can use the number of moles of hydrochloric acid as our basis in finding the volume of carbon dioxide gas produced in the reaction. All right. So in just a short while, we will continue determining the amount of or the number of moles of carbon dioxide gas, all right, that is produced in this reaction, and eventually determine the volume in liters of that amount of carbon dioxide gas. All right, so to continue with our computation for the number of moles of one of the products, carbon dioxide gas, all right, based on this balance equation, all right, the 2 moles of hydrochloric acid, okay, when made to react with calcium carbonate, will produce 1 mole of the carbon dioxide gas, right? So we can set our number of moles for carbon dioxide gas given the 0.600 mole of hydrochloric acid, all right, that we calculated earlier, right? So that means our target variable now is to determine the x mole of carbon dioxide, all right, given that the available number of moles of hydrochloric acid is 0.600, all right. So we just translate this into a ratio and proportion equation, all right, which will be in the form of, all right, x, which is the number of moles of the carbon dioxide gas that will be produced, okay, is determined simply by multiplying 1 mole of carbon dioxide gas, all right, uh, by the amount of, or the number of moles of hydrochloric acid, all right, that's available as computed earlier, 0.600 moles. And then divide this by the number of moles of hydrochloric acid as defined by our equation or the stoichiometric uh, ratio. All right. So when you do our math, we will get the value of X equal to 0.300 moles of carbon dioxide. Moles hydrochloric acid gets cancelled. All right. That's why this value of 0.300 okay, represents the number of moles of the product or one of the products, carbon dioxide gas. And since we're asked to find the volume, all right, the volume of the carbon dioxide gas in liters at a pressure equal to 745 millimeters mercury, right? Which is the same as 745 torr, all right? Which when converted to atmosphere, all right, we have here the conversion factor. In 1 atmosphere, we have 760 torr, all right? So 745 torr, therefore, is just equal to 0.980 atmospheres. And using our formula for the ideal gas law equation, all right, where the volume, capital V, is just equal to the product of the number of moles represented by letter N multiplied by the value of the universal gas constant, all right, and then multiplied also by the Kelvin temperature, capital T. So the product will be divided by the pressure, small p, represents the given pressure P, all right? So when you substitute, all right, we get 0.300 moles, that's the value of N, multiplied by the value of capital R, which is 0.0821 liter atmosphere per Kelvin per mole, all right? We are using the 3 significant digits for this value of capital R. And then multiply also by the Kelvin temperature of 296 Kelvin, after which we will divide the whole thing by the pressure already expressed in atmospheres, 0.980 atmospheres. So again, doing our math, we will arrive at the value of the volume, capital B, equal to 7.44 liters in 3 significant figures. Right? Now, for question letter B, where we are asked to find the volume, B sub 2, all right? Using the general gas law, all right, or the combined gas laws, where in finding the final volume V sub 2, we just multiply, okay, the initial pressure P1 by the initial volume V sub 1, then multiply that by the final temperature T sub 2, and then divide by the product of the new pressure P sub 2 and by the initial temperature T sub 1. Alright? So substituting V sub 2 is just equal to 0.980 atmosphere. This is the value of the initial pressure times 7.44 liters, that is the initial volume, and then multiplied by the final temperature 273 Kelvin, then divided by the product of the new pressure, which is 1.00 atmosphere. Okay, that is to be multiplied first by the initial temperature 296 Kelvin. So finally, doing our math, we will get the new volume V sub 2 equal to 6.72 liters, also in three significant figures. Alright? So, we are done. Okay? Till the next episode, mabuhay. Masya Allah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.